Our webinar topic today is going to be CV programming, DCC myths, and more. And what we're going to do is we're going to dive into a lot more of this. First off, introduce myself. My name is George Bogatuk. I'm our product specialist and salesperson here at SoundTraxx. So first thing, let's go ahead and kind of overview what we're going to do. So our overview is we're going to overcome the intimidation. Traveling around a lot, I hear all the time how people are afraid to do this or afraid to do that, and they don't want to break anything, they don't want to ruin anything. So as long as they can get enough that they get by, they're happy. And so what I want to do is try to help overcome the intimidation. So we're going to dive a lot deeper into CV programming. We're also going to talk a little bit more about these myths that exist in DCC and kind of help simplify them and answer some of those common questions that you're going to see or hear with what's going on with DCC. Once upon a time, I was on the other side of this camera, and I was kind of like you, where I didn't know as much, and unfortunately there really isn't a whole lot of information out there. So by spending the time and doing this webinar and kind of helping unveil the cloak, if you will, to kind of see what's going on behind the scenes, hopefully this will give you guys the courage that you need to play with things and try it out. Towards the end, we're going to cover some troubleshooting tips, and then the whole point of this is to overcome all of this to help with your enjoyment. I mean, this is all supposed to be fun, and if you're limiting yourself because of either apprehension or you're afraid something's too technical, take the leap. All I can tell you guys is, personal story. Some of you may have heard this already, but years ago, before I had the name on my shirt, I actually had bought my DCC system, went home, started reading the manual. It sounded like it was Greek to me, and I was like, I didn't understand what was going on. And so I put it away and said, well, I don't feel like doing it now. I just need to walk away for a minute, and then I'll come back and figure it out. Well, it ended up to be 2 years. And at the time, I was using a product called Rail Command, which was a carrier system that had all the memory stored in the base unit. And that was working just fine. Well, as more and more popular DCC became, I said, well, wait a minute, I've already made the hardest part. I've already spent the money. So now I've got, X number of $100 sitting on a shelf. So I brought it out, took it in, looked at it, read it, bought a decoder, plugged it in, put it on the track, and realized, hey, this isn't as complicated as it may sound. And so with that, we're going to kind of go into some of that to try to help make this a little easier for you guys, because anybody can get in there and do it. It's just a matter of the will to get in there and will to learn it, try it out, and we're going to give you some tips and hints on all the stuff that's going on. So as we get on with this, we'll go ahead and start talking about configuration variables. A configuration variable, also known as a CV, is a way that it allows us to adjust the way the decoder behaves. We're basically varying the configuration or the setup of your locomotive to make sure that the locomotive or the decoder behaves the way you expect it to. Now, in some cases, there are some industry standard CVs. These are things like where the addresses are stored. CV29 is another good standard, and so forth. There's some of those that do have different things that they do, and if you adhere, you use that one, and everybody's pretty much universally accepted. There are other that are some manufacturer-specific CVs. And for example, SoundTraxx with our Tsunami 2, we have a feature that we've talked about in past webinars and on our YouTube channel called Dynamic Digital Exhaust. And the Dynamic Digital Exhaust allows you to have the sound of the exhaust of the locomotive, whether it be an exhaust chuff or prime mover exhaust. It will behave differently based on what the locomotive is doing. Now, because nobody else has those features, we have to have manufacturer-specific CVs that allow you to customize the performance and the behavior of the decoder and of the locomotive. Not all decoders support all CVs, and a case in point might be a volume control, for example, CV128. On a non-sound motor decoder, there's no volume control, so CV128 doesn't do anything. Now, if you were to set CV128 on a motor decoder that doesn't support it, the decoder is going to say, okay, but I don't have it, so whatever, and it will not change the behavior because the decoder doesn't have that to do anything in itself. So this is where you have to look at what your decoders are and how they work and make sure you have the right CVs, but make sure you're using the right list. Now, the one thing I want to point out here is not all CVs can be programmed by all DCC systems. And most of the ones that have been made in the last 5 years, at least probably 10 years, can probably program any CVs. But some of the early DCC systems, if you still have some of the original Zephyr DCS50, for example, they can only program up to CVs 256. Same with some of the early release power cabs. We had somebody call up within the last few weeks, asked about trying to program CV, I think it was 512 or 503 for the dynamic digital exhaust, and their power cab had not been updated in quite some time and could only program up to CVs 255. And so you have to look at what your version is and double check with the manufacturer of your DCC system, because many of them offer upgrades or updates, things like that. You may be able to even do it via the miracle of the internet. So take a look at that and make sure what your capabilities and limitations are. Now, when we talk about the CVs, each CV is comprised of 8 bits. Now, when we look at the structure of the CV here, we're going to go ahead and see the diagram. And if you look at this, every CV is built exactly the same way. There are 8 bits, and each bit is worth a value. And if you look closely at the chart here, you're going to see that each bit doubles as it works away across. So a value of 1, a value of 2, 4, 8, 16, 32, 64, and 128. Now, each of these bits are either on and off, and this is where the digital term comes in, because digital means either a 1 or a 0, and this series of 1s and 0s relay the information. And so if you want a particular bit on, you're going to set that bit to a value of 1, or the bit to 1, and if you want it off, it's going to be 0. When the bits are on, you're going to add the weight of each of those bits together to create a final value. And that final value is then stored in the decoder under the CV, and the decoder knows what to do with it. Now, every number between 0 and 255 is a unique combination of these bits, either on or off. So looking at the example there, we have bit 1, which is worth a value of 2, and then we have bit 4, which is worth a value of 16. Those are both on, and the other bits are off, set to 0. So we add the 16 and the 2, and we come up with 18. If we wanted to add, let's say, for example, bit 5. So we added that, and we're going to go 32 plus 16 is 48, plus 2 equals 50. So each value that you create of a CV is a unique combination of those bits on and off. And so this is where the decoder uses this for configuration. Now, there are some CVs that can be used as a simple percentage. For example, volume control. Volume is 0 to 255, basically 0 to 100%. And the bits are still structured exactly the same way, but the meaning of that CV is unique in that we've programmed it to where it's 0 to 255 equals 0 to 100%. Now, there are other CVs that you can do that each bit has a particular purpose. And in this particular bit here, I took CV 112 out of our Tsunami 2, and this shows you how the structure is. Each of those have a purpose, and if you look at the definition inside of there, the first 2 bits, the combination of those 2 determine the fuel type. So on this particular one, you can select a wood-burning locomotive, a hand-shoveled coal, auger-fed coal, or an oil burner. Now, because there's 4 options, we have off-off, on-off, off-on, and on-on. That's our 4 choices. And so the values of those are 1 and 2. So basically, a value from 0 to 3 determines what fuel is being used. Now, the next one is the injector, and this determines whether you're using a lifting injector or a non-lifting type injector. The next one is the type of power reverse, or the reverser, whether it's a power reverse or a manual Johnson bar. And you work your way through and you determine which things on this particular one are important. Now, when you see this CV like this doesn't mean much to you, but if you refer to the user's guide and look at this CV, it will walk you through how to build a CV value. So let's just, for argument's sake, say here we wanted to do a simple articulated locomotive, which is value bit number 7 worth a value of 128. We wanted to do I'm going to say manual shovel coal because that's the one I remember off the top of my head. And we want to do a lifting type injector and a power reverse. So based on the way this is done, the first 2 bits are both set to 0. The injector, to choose a non-lifting type injector, is set to 0. But to select the power reverse, we're going to turn that on. That's worth a value of 8. Then we would turn off the 3-cylinder, and in this case we're going to turn off the wheel slip. So we're going to turn off those 2, and then we enable the articulated. So in this case we're going to do 128 plus 8 equals a value of 136. And so you can see how that CV is come together and how it's structured. So you can go through, and like I said, the user's guide will explain how all this works in detail, but this is kind of an example of how the CV is structured to do different things for each bit. So when you go through the user's guide, it'll explain how this works. Once you understand how that works and know it in your head, then you can always refer to the technical reference where you're going to see CVs structured out just like this and just give you the quick rundown on what they do and what they mean. So the next one is when you're changing CVs. When we're doing all of this, the problem is that when DCC was designed, they let the engineers name the terms. And so you have words like programming and bits, and you have to know all of this stuff and kind of somewhat understand what's going on in order to be able to read the documents and see what's going on. But you're not actually programming the decoder. This to me is one of the biggest misnomers in DCC, because our engineers write the program on their computer. They tell the decoder how to behave, and then you can then select from those choices to find out how to make the decoder behave for you. Which are the choices we give you. So for example, when you're changing the volume on your television, you're essentially doing the same thing. It's just you're using a remote control of some form, or you're using a volume knob. Where in DCC now you have to go in and change CV 128 to a value of 0 to 255. You're not programming the volume, you're just making the change. Now, one of the things I want to point out, when you're using SoundTraxx products, you cannot break the decoder by using the wrong CV value. So let's say, for example, horn selection. In our diesel decoder, you have 44 different air horns. So 0 to 43 are your choice numbers. If you program CV 120, say to a value of 50, you could potentially, in theory, say that, wait, 50 is beyond the range, the decoder doesn't know what to do, and it goes into panic. But with our decoders, if you pick beyond the range that's given, the decoder ignores that and reverts back to the default value of 0. And so therefore, if you accidentally pick horn number 50, the decoder is going to say, don't worry, we got your back, we're going to fix it. You can always go back and reprogram the CV again once you realize you made the mistake. Now, to do this, when we get a decoder coming out of engineering and they say, hey, all right, we're done, we just need to test this thing, make sure it works. We get a book that's about 1.5 inches to 2 inches thick that we have to go through, and we take this with different DCC systems and we program each CV page by page, CV by CV, value by value, and this way we can make sure that when the decoder is programmed to a CV value, that A, it does what it's supposed to do, B, it does not adversely affect something else in the decoder, and C, that if you go beyond the range, it's not going to turn it into a paperweight. Because this way, nothing's more frustrating than when you're programming a CV. Let's just say you hit the wrong button by accident. And when you hit that button, you hit the enter button, and you go to make your programming change, suddenly now your decoder goes quiet, it's dead. What happened? Now you have to send it back to us to fix it. That's not fun. And so we want to make sure that you have the fun. So if you make a mistake, there's a safety net there so you don't have to worry too much about setting the wrong CVs. So once we change a CV, there's 2 ways of changing a CV or configuration variable. The first of which is called service mode or programming track. The other one is called operations mode, known as programming on the mainline programming, ops mode programming, programming on the fly, things like that. So let's dive into both of them. The first one is known as the programming track or service mode. Now what this does is this takes a small isolated piece of track and allows your decoder to be isolated from the wild, so to speak. So you can simply take a couple of pieces of Kato Unitrack or a small section of Flex Track or something like that, set it on there and set that to your programming track outputs on your DCC system. Now, what this does is this allows you to communicate to that decoder, and being isolated, you're able to communicate back and forth with the decoder. The reason this is done is because the way a programming set is done is kind of a little different. So when we talked about in our past webinar talking about DCC, the command on the main line is, hey everybody listen up, locomotive 1000, perform XYZ task and go for it. But when we're on the programming track, we have to be able to recover our decoder. Say for example we lost an address, or say we bought that locomotive and somebody had already been playing with it and set it to some other address that we don't know. The isolated programming track allows us to communicate to that decoder without a prefix address, so that way the decoder can be talked to without commands being ignored. Now, when you're on the isolated programming track, you can also read CV values. The way a decoder is read on the programming track is basically a lot different than what you would expect. So most people would expect the DCC system says, hey decoder, what's the value in CV29? And the decoder says 6. What actually happens is a lot different than that. So when we were all kids, we all played the game 20 questions with our friends, right? Well, think of this as a game of 256 questions, starting with, is the value of CV29 0? The decoder says no. Okay, is the value of CV29 255? And the decoder says no. Is the value 1, 2, 3, 4, 5, 6? The decoder finally says yes. So the DCC system gets that acknowledgement from the decoder and displays that screen or that answer in your window, CV29 equals 6. Now the way it's actually yes and no is when the decoder answers no, nothing happens. So the DCC system then moves on to the next question. When the decoder answers yes, it will draw a surge in current internally or through the motor circuit. And that's when this isolated piece of track pays off, because we don't have anything else that's going to draw a current and surge. So the DCC system can say, I am getting that acknowledgement from the decoder I'm intending, so therefore that is the correct answer. So once the DCC system detects that surge in current, it says, I've got the answer, I'm good to go, displays it in our window. So that's why when you go to read a CV value, you notice that if the value is higher, say a value of 220 or something like that, it takes a lot longer for that answer to come through, because it's asked 221 questions before it got to that. The other thing is, as I mentioned, the locomotive address is not required, because when you're sending on the programming track, it basically says, hey decoder, do this. In this case, hey decoder, program CV29 to a value of 6. And the decoder does it, because the way that this command is written is slightly different than what it is on the main line. The other caveat here is, on your small programming track, you cannot test the locomotive settings, because the protocol on the programming track is different than what's on the main line. Your decoder should sit there, be quiet, and just communicate yes and no with the command station. If you're getting noise on the programming track, you either have a power leak getting to the programming track or something else is wrong, contact our service department. Last thing I'll talk about on the programming track is, with our previous generation decoders, we did require a programming track booster. With our new generation, the Econami and the Tsunami 2, a programming track booster is no longer necessary, but the advantage is that you do not have to remove it if you're programming one of our new decoders. So if you've got a programming track booster, one of the SoundTraxx PTB100s, you'll have those visual indicators, the lights on the PTB that will tell you where the programming is, so you can actually see what's happening on the programming track. So you don't need to remove it, but it's not going to damage it if you put a decoder on there that requires or does not require a booster. So next mode is what's called operations mode programming, programming on the main, programming on the fly, those type of things. Now here's the best part is you don't need to place a loco on a special track or shut the layout down. I don't have to pick it up, so delicate detail parts, things like that, don't worry about getting damaged. I can hear the immediate results. So when I program a CV on the main line, I will instantly hear that volume change, for example. I cannot read the CVs because going back to our method, how we read a CV, if I'm trying to read a CV on the main line and say Jim Bob over on the other side of the layout tries to move his locomotive at the time it's trying to read, well, on the main line, that's going to be a change in the current draw. So it's going to produce a false read. So that's why the isolated programming track allows you to read. Now the catch here is you absolutely have to know the locomotive's address. When you're programming, the programming on the mainline commands are no different than what it is when you're trying to blow the whistle or ring the bell. You go into your throttle and it says address. So the command comes out, hey everybody listen up, locomotive 1000, change CV29 to a value of 6. And then of course the decoder says, hey, I'm address 1000. Okay, I'm going to change CV29 to 6. So you'll instantly hear it. Same thing with volume controls. You'll hear that change. Hey locomotive 1000, listen up, or hey all locomotives, listen up, locomotive 1000, change CV 128 to a value of 100. And so it's going to reduce the volume. You'll instantly hear those changes. So the way you can test to make sure you can program on the main line is make sure you can run it using a throttle. So if you can talk to the locomotive, you can say, okay, locomotive 1000, I can move you forward, blow your horn, whatever. Then the decoder is going to respond to your programming on the main. Now, I will tell you this is something that I use primarily on all of my decoders because I have a standard set of CVs, like for example, volume control, and I go in and just program the CVs on the main line. I can instantly hear the changes, make sure they're within the tolerances of what I want. And go from there. I can set up even the address on the main line. So you're not limited except in one case, and you cannot make changes to the active type of address. So when you get your decoder, it's set to a short address 3. If you try to change it to another short address, say address 20, the decoder is going to ignore that command. And the reason for that is if you're trying to program a lighting effect, say in CV51, and we go through and we're pushing the buttons on here, and we didn't push the 5, we pushed the 1, we hit the enter button. In our mind, we think we're programming CV51, but in reality, we're actually programming CV1. CV1 is where the short address is stored. So then I type in my number, and I hit the enter button, and I've just changed the address on my decoder. Unbeknownst to me, I was trying to change a lighting effect. Why did I lose control of my decoder? So with that safety net, you cannot change the active address, but you can change to the inactive. Now, going back to what we talked about, every decoder has 2 addresses. You have the short address or basic simple address stored in CV1, or you have the long and extended address stored in CV 17 and 18. Now I can take CV locomotive 3 and I can change it to address 1000 on the main line without any problem, because it's assuming if you're changing the address to the other type, it's intended, because you have to push more buttons to do it. So I like programming on the main. You've got a full powered programming track. You can instantly hear and see changes and go that way. Now, common myths we'll get into here. First one, ops mode or programming on the main is going to reprogram everything on the layout. So I hear this all the time. Clubs ban mainline programming all the time. Well, there are some systems, including the NCE Power Cab, and I know, for example, the Digitrax large system, and I apologize, I forgot to look this up. It was the DCS 200 or DB 200, whatever they called it. Their programming track outputs were the same outputs as your mainline. When you wanted to use the programming track, you were supposed to throw a toggle switch to divert power away from your main line and to the programming track. Well, somewhere, and I'm sure it happened quite common, not everybody knew that. So though we went to go change the address on the programming track, their locomotive's sitting there, and they go to change it, and everybody's mainline program, because we talked about the programming track command is not address dependent. And so any decoder that hears that is going to respond to the command. And so because of that, somebody somewhere set everybody's address, and they got panicked, and so they said no more programming on the main line. Well, again, learn your DCC system. Make sure you understand how it works. When you're programming on the main line, it is address dependent, and the command is only going to the decoder that it's intended for. Now, if you have two address 1000s on the layout, yes, both of those are going to get reprogrammed. So just be cautious. Know what it is. It is a myth. Don't be afraid of it. It'll be your friend, and you'll realize that you'll be able to do a lot of stuff that you couldn't do before by programming on the main. Now, I kind of touched on this a minute ago. You need a programming track booster. You don't really need a booster on your programming track anymore, especially with the Econami or the Tsunami 2. If you're still using original Tsunamis, yes, you can leave the booster on there. You can program your decoders just fine with it on there. The one thing I will tell you is there is another product out there that's not made by SoundTraxx called a Power Packs. And the Power Packs is relying on a higher current draw than what the NMRA recommends. And again, difference between recommended and standard. And so what will happen is, because with the Econami and the Tsunami 2, the acknowledgement pulse is internal following the NMRA recommended practice. But the Power Packs is looking for a higher current draw that typically would go through the motor. You may not be able to read using the Power Packs. You still can program because the programming command is still being sent through. You just won't be able to know that the decoder acknowledged that it got the command on the programming track. So if you experience issues with the Power Packs, just bypass it with the Econami or the Tsunami 2 and you'll be fine. Or, cheap shameless plug, you can always put a SoundTraxx PTB 100 in place of it. One thing here is all sound decoders are the same, and that's simply not true. SoundTraxx has gone through a lot of effort to make sure that we're bringing you the best decoder, the most customizable, to give it to where you can operate your decoder the way you want it. And as we talked about, with not all CVs adjusted between all brands. For example, Tsunami 2, with all of the different sound effects, there's over 50 different sound effects built into the Tsunami 2 Steam. Our competitors don't have that. And one of the things we have is we have a sound volume control CV for every one of those sound effects. So you can go through and adjust how loud your snifter valve is, or you can adjust how loud the injector volume is, and so forth. Whereas some of our competitors will have whistle volume, bell volume, exhaust volume, background sounds. And so not all decoders are built the same. So when you're going through, make sure you understand the features and benefits of each brand. And with our SoundTraxx products, the Tsunami 2 and the Econami, look at our YouTube channel. We've got a lot of videos up there showing you all of the cool things you can do with it. So be sure to check those out. Like and subscribe. We're posting new videos every week. Now the last one here, as I'll point out, is all DCC systems are the same. It's not true. There are some differences. When it comes to DCC, as we've talked about, the standard applies to the signal that's sent on the track. So the signal that's coming to your mainline track is standardized in such a form that every decoder can receive that signal, whether it's made by us or somebody else. But when you look at the different systems, we look at the different options and what you have. And so when we're looking at this, we look at the different user inputs. And the user input is typically the throttle or the handheld. And with that, you have operator throttles versus full-featured throttles. And the problem with some of these is these operator throttles can't access a lot of these higher functions. So for example, F17 is on our diesel locomotive is a fueling option. So you can actually take on fuel. Well, if you're running your layout and you have a fueling rack in line, one of the layouts I had gone and operated on, which unfortunately is being dismantled as we speak, had actually a spot where you had to stop and take on fuel. So you would run your diesels in, you would stop at the fueling rack, and here you can turn on function 17 and you can hear the sounds of the locomotives taking on fuel. You run over the refrigerator, get yourself a soda, come back, turn off F17, and then you can start your way. I've also been to other layouts where you have to take on fuel and water coal and water during the operating session, and that's function 16 and 17 on our steam. Well, these operator throttles, if you're very limiting, you can't reproduce all of that. So this is where you have to kind of take into account what your options are and what you want to do. Now, with our flex map, you can decide those fueling sounds are in those 8 functions, and so you can adjust for yourself. But the other thing here is how the DCC signal is sent. The one thing I've noticed over the years is DigiTraxx sends out a full DCC signal packet. What that means is that it's sending out a full command every time. So if your locomotive is running along, loses power, comes back on, all of your functions are going to match the state again and continue on. NCE, on the other hand, sends out continuous motor commands, but will only send function commands when a function state changes. And that means when function 0 or whatever is turned from off to on or on to off. It's up to you. But it will only send a function command out. The reason I point these out is because you can get some different behavior with how your decoder runs. For example, if I take a DigiTraxx throttle here, I'll use that DT400 throttle that's on your screen, and I have the same address programmed on both throttles, on the left throttle and the right throttle. Well, that full command is being sent out, even if that function, even if that command is locomotive 1000, speed step 0, turn all your functions off. It's still an active throttle and an active command. So if I take the other throttle and turn on F3, which with our products, F3 blows the short whistle, both on and off. So when you turn the function on, you hear the whistle. When you turn it off, you hear the whistle. Well, on this throttle and the DigiTraxx system, if one throttle is telling it to turn F3 on, the other's telling it to turn F3 off, you're going to get a constant honk, 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 honk as the decoder's just simply behaving and doing what it's told. This is again where knowing your DCC system comes into play. With NCE, again, they don't send out the full packet. So let's say, for argument's sake, say your locomotive's running down the track and it loses power for a second, comes back on, continues running, but now your light's off. Well, if your headlight, when you turn the headlight on, if your F3 was on, this now sends out the packet to tell the decoder, hey, turn on F0, turn on F3. You're going to hear the short horn play even though you were pushing the 0 key, because again, it's sending that function state out. So kind of understand what's happening behind the scenes. I will tell you I'm not as familiar with some of the other DCC systems, so I'm sure there's some idiosyncrasies between each of those. And again, it just depends on how the system was designed and how it operates. So know your system, know how it works, and decide how you want to run your layout and what works best for you. So moving into some common troubleshooting things. These are just some things that we get questions on all the time. First of which here is the blue pilot light. You see the blue pilot light. It just indicates track power's there. We get a lot of calls where somebody will say, I put the decoder, it's on the track, I'm not getting any sound, I'm not getting any motion, what's going on? And the first question we're going to ask you is the blue pilot light on? Because we need to know if the decoder is getting power. If the decoder doesn't have power, it can't operate. So that's one of those safety nets in there. If it's visible through, especially a lot of the modern diesels, you see open fan grills, things like that. If it's visible, you can either put a piece of tape behind the grill or put a piece of foam there or something that you can kind of muffle that up, or you can put a little dab of paint over it if you want to tone it down. But the biggest thing is just make sure you know it's there, so that way if you do have to run into that question, you'll have access. One thing we get asked about, the lights start flashing, what does that mean? Well, on our decoders, going back to the Tsunami and probably even farther, I'll be honest, I didn't use the LC series all that much myself, but the lights will flash a certain number of times, and that number of flashes corresponds to an error code. It's trying to tell you what's happening. So for example, if your headlight flashes 10 times, that's trying to tell you the decoder is seeing spikes of track voltage that are equaling 21 volts or more. And so you want to make sure to fix that problem before you damage the decoder. There is a list of these codes at the back of the user's guide. So SoundTraxx.com, under the manuals tab, get the user's guide, and under the troubleshooting section, it'll give you a list of how many flashes equals what. Most of you guys are familiar with the CV reset. CV8 equals 8. Cycle the power, the lights flash 16 times, and that's your indicator to let you know that the reset has in fact taken place. Now another one we get is LEDs do not illuminate. Well, I wired everything up, but my lights don't work. What's going on? Most of the time we ask the question then, are you using LEDs or light bulbs? And the reason is LEDs are polarity sensitive, whereas light bulbs are not. So light bulb, you take the two wires, one to the common, one to the function output, the light turns on, you're good to go. But with an LED, they're polarity sensitive. So your positive lead will need to be attached to the blue wire, and the negative lead will need to be attached to the function output. Now, if you're not sure which polarity is which, I've built myself a little tester, and this is where I've taken just a simple 9-volt battery, and I've soldered a small resistor, a 1,000 ohm resistor, to one lead, and this happens to be on the positive side. So what I can do is I can take the wires going to my LED, and I can quickly touch it to these two terminals, one to the tip of the resistor and one to the negative terminal. And first of all, that tests the LED to make sure it lights, but it also allows me to confirm polarity. So when I'm actually wiring it to the decoder, I can make sure that my polarity is correct. So once you have that in there, again, when you're wiring in your LEDs, you want to make sure you put your resistor in there. Again, typically I use 1,000 ohm. They're common, they're easy to get a hold of. It's probably a little more than what's necessary or a higher value, but it's not going to significantly dim the headlight to the point where you can't see it. You can adjust that down or even higher if you want to do a dim light. One of the ones we get also, locomotive runs in the opposite direction of what the lights are. And one of the things is if you get the motor polarity wrong, then your locomotive may run physically reverse, but your headlights are correct. The good thing is you can always pop the shell off, flip those wires from the motor, put it back together, and you're good to go. If you don't want to do that, you can always do it digitally. CV29 reverses the normal direction of travel so that your motor direction will match the indication on your throttle. The other thing is then you just have to reverse the lights to match forward and reverse to make sure that you get the lights on the right end. The last one here, this one's a really common one. The sound is playing, but I have no control. What's wrong with the decoder? What's actually probably happening, if you've got sound playing on your locomotive and it's sitting there, but you're pushing buttons and it's not doing anything, there's a greater than 0 chance you have the address set to the different than what you think it is. So for example, if we have a locomotive address 1000 and I'm selected 100 here, no matter how much I will that locomotive to take the command, it's ignoring it because it's not sent to its address. So going back to what we talked about earlier with the programming track, you can always pick it up, put it on your isolated programming track, talk to the decoder, find out, make sure that it's responding and acknowledging programming commands by reading CV8. It should come back 141. Then you can go in and set an address or interrogate and find out what the address is. So that's where your programming track comes into play. Very rare instances will you ever have anything more catastrophic, but 9 times out of 10, probably even higher than that, 90%, 95% of the time, you're actually going to just have the wrong address programmed in there, set it on the programming track and interrogate it. The other option here is sometimes an advanced consist. If it's set in there, CV19 is set to a non-zero value. It's ignoring motor commands from your throttle, but you can blow the horn and ring the bell. So these are things, again, know what's going on behind the scenes and play with it. So with this, I will briefly talk about the Java Model Railroad interface, the JMRI or Decoder Pro. We do get a lot of people that use this. And I want to make sure I point out that I do think this is a fantastic thing that has come out for model railroaders. It has helped make CV programming a lot easier. But the biggest things I want to point out here, number one, is it's not a substitute for the manual. Our user's guide goes into detail to explain how the features work. If you go to the JMRI, for example, and you look at this and these checkboxes and slider bars don't make sense to you, get our manual. Learn how we told you how the decoder works, read all that up, and then look at the checkboxes and slider bars again and make your selections. It's really a great tool, but like I said, there have been issues where we'll have people call up and say, hey, I've been I'm trying to get your whatever, your XYZ feature to work and I can't get it to work. We'll say, okay, well, what CVs are you programming? And I'll get back a lot of times, I don't know, I'm using Decoder Pro. And so my answer to that is stop using Decoder Pro, grab our manual, listen to how we tell you the feature works, and then go back, program the CVs directly, again, using your throttle. Make sure the decoder behaves the way you want it to, and then you can always go back, put it on the programming track, and read all changes, and it'll highlight what CVs have changed from the last time it was programmed. And that way you can see either you misread an interpretation of the checkbox or the slider bar, or the folks at JMRI may have misinterpreted a manual. These guys are fantastic volunteers, but they are volunteers and they don't work for us. And so therefore, you know, they're programming it just as if you would be reading the manual and interpreting it into checkboxes and slider bars. So because of that, we cannot offer assistance with helping with the JMRI program. We do a lot of work with our own decoders. I can tell you how to set CVs and to make our decoders do all kinds of cool stuff. But if you're limited on saying, you know, I have to use the JMRI or I have to use the Decoder Pro, then there's only so much help I can give you, because I'm going to give you the CV numbers and the values to set so that you can make the decoder do what you want it to do. A couple other little side notes on here. It does need a computer connected to your DCC system. So say, for example, if you're just wanting to change the volume, if you have to boot that other computer up, connect it, make sure it's on, program it on the JMRI, and then hit program. In 3 seconds, you could be done programming a CV if you understand and know your DCC system. Basically, what's happening with the JMRI is it's telling the DCC system to then send a programming command. So you have two methods of protocol or communication protocol: the computer to the DCC system and then the DCC system to the decoder. It just opens up more possibilities. So if you have an issue reading, make sure you can read it with your throttle first or on your programming track with the DCC system. And then if it can, then you have to check the connections between your JMRI and your computer. The other thing is every system has its own settings. So if you have an NCE system, you have to go in and set this up. If you have a Digitrax, you go set this up. If you have MRC, you have to go set it up differently. And so, you know, take the time and do it. Like I said, I'm not trying to knock it. I think it's a fantastic tool. And one of the best things I think that JMRI offers is that once you build a locomotive the way you want it, you can save that profile. And so when you build your next locomotive that's the same one and you want to program it the same way, just with a different address, you can put it on the programming track and hit write all sheets, and it will then preload all of the settings from the previous locomotive into that one, and then you can go in, simply change the address, save it as a different profile, and now you have two locomotives that are identical within a matter of seconds. So it is a great tool, but just be cautious. If you have problems, use our manual first. So in conclusion here, we're going to go ahead and just kind of cover some last tips here. Again, I've mentioned our YouTube channel. We've been posting videos on there every week. Make sure you like and subscribe to it to make sure that you're getting the newest information. Also, if you're not already subscribed to our Facebook page or following our Facebook page, be sure to do that, because occasionally we'll post short little video clips on there as well. You're also welcome to interact with us there as well. We do try to get back to you fairly quickly during normal business hours. I've mentioned this that a lot of times our steam and diesel users guide are designed to be very helpful. We do want to make sure that we've given you a lot of information so that you can decide how to make the decoder set up for your own personal tastes. And then other tips at SoundTraxx.com. The next webinar, we're going to get into installations. We're going to kind of go an overview of what the decoder install takes and what kind of things we need to look and keep in mind. So be sure to subscribe to our newsletter to make sure you get updates on when we announce that. We're looking at travel schedule, and we're going to try to get that scheduled here this week. So